Good morning. So I know that you guys are the committed DevDays attendees coming to the first 9 o'clock session straight after the social event. Happy to be here. So yeah, my name's Brendan. I work for Microsoft. I'm an engineer, and my focus is the FHIR Server for Azure. So excited to be here today because it is definitely one of my favorite topics to talk about. And in fact, it's one of my favorite things to work on as well. And hacking it is one of my favorite things to do with it. So what I want you guys to walk out of this session today with is I want everyone after the session, or sometime today, to go ahead and fork or clone the FHIR Server for Azure repository. So the whole point of this session is to give you a little bit of an introduction to that, so you'll know exactly what to expect, so that when you get there, loosely how the code is structured, and sort of how to start contributing. So I just want to do a quick raise of hands on a few things. So it doesn't have to be with our server, but here is, does anyone sort of have experience sort of implementing the FHIR REST API, like in your own applications? Yeah, cool. So a good number of people. So then I thought, well, there's also kind of another good use case. So are there people here that also would like an existing FHIR server, so an existing code base, where you can kind of prototype, play around with it, extend it, try new operations and features. Whoa, something has happened to PowerPoint. It's crashed. It's all good. Anyway, let me finish up that question first. Yeah, so is anyone looking for an existing code base where they can kind of prototype features, prototype your applications against it? So is anyone, so that's sort of in that yep, so in that bucket as well. And for everyone else here that didn't raise their hands, or social event, kind of lacking a little energy this morning, I really hope that you'll get something out of this as well. We will have a few slides just for architectural reasons, but then I also have a bunch of code to sort of show you how everything is structured and how to start contributing. Just going to try this this PowerPoint thing one more time. All right, I've never had an actual PowerPoint deck fail. All right. So the agenda, yep, so like I said, we'll go over the use cases for the FHIR Server for Azure, when you should use it or when you could use it. Then I'm going to get on to actually showing you some code, so hacking and extending. So in this presentation, I want to show you how to quickly add a very simple data layer. So this data layer that I'll be showing today is kind of the simplest example that I can think of. So hopefully that sort of, if you were trying to adapt to a new data source, and we'll sort of go into that in a little bit more depth, it sort of gives you that base groundwork or that base structure that you can sort of use to implement it against something that you already have. And then how to add a feature. So how to pick up an item. In this case, I want to take us through how to add some basic functionality for $validate. So our server currently doesn't do that, but we're going to implement some of that on stage today. And then contributing and basically what to expect. So I'll show some screenshots of the GitHub repository and sort of explain the processes and the pipelines that we have set up. So kind of ease you into what to expect when you're contributing on there. Okay, so the overview. And if you came to my colleague Michael's presentation earlier in the week, you would have seen this same slide. But for everyone who's new to this session today, I'd like to just go through it one more time. So we have two products. Both have the word FHIR and Azure in them, so maybe a little confusing. So we have the FHIR Server for Azure, which is what I'm talking about today, and the one that we give all the source code away, so you can download all of that off GitHub. Then we have the Azure API for FHIR. So the bits that we compile from the FHIR Server for Azure, we host in the managed runtime, in the managed service environment, Azure API for FHIR. So just to drill into those in a little bit more depth, so the FHIR Server for Azure implemented in C#. We currently support Stu 3 and R4. We have a whole bunch of search already implemented. We have 2 data providers for you to pick from. So we do Azure CosmosDB and also Azure SQL Provider. Today we're going to add another one, which is going to be a little file-based data provider. So yeah, it's definitely there for you to, full transparency, download it, prototype with it, experiment with it, add your own features, contribute back if you come up with something good. And then the Azure API for FHIR. So the picture there is a picture of the Azure portal. So literally, you just sort of type in the name that you want your instance to be. We'll give you that subdomain, and we'll spin up the endpoint ready to go. So we'll take care of all the database provisioning, the infrastructure, the scalability, the uptime, the compliance, the updates. So you don't have to worry about anything. So if you are trying to get like an API into production, this is definitely a good path to follow. All right, so I really wanted to show this slide as well. So I cannot believe that DevDays 2018 here in Amsterdam, we brought along this little slide on your left, which was the FHIR Server for Azure. So you may have seen us in the Microsoft shirts, walking around kind of looking a little bit like proud parents. We just announced the FHIR Server for Azure as open source. Back then, we had a Stu3 implementation. We had just one data layer, the CosmosDB one. And we had like a whole raft of kind of like all the search basics implemented and ready to go. So yeah, we were super excited about that. And I cannot believe that it's only been 12 months. So DevDays 2019, the team has been very, very busy. So since then, we've added in R4 support. We've got a very high fidelity SQL data layer. So we're still adding features to this. So we have now advanced search, things like include, chains. I think there's PRs currently going in there right now for things like transactions. We have a bulk export provider implemented in the open source right now. We've added conditional creates and updates. So there's a whole bunch of stuff that we've been doing in the last year. And when I was talking about this with the team yesterday, I seriously cannot believe how much stuff that has changed in that 12 months. And I also wanted to point out there's a link at the bottom, which you may not be able to see, but so there's like a releases page on the open source project. So if you want to see in like granular detail exactly what we're releasing, you can sort of head over there and sort of see what's going out in each of the packages. All right, but it is also worth noting that everything you see in open source is not instantly available in the Azure API for FHIR, so our hosted solution. We sort of consider the features once they're sort of very mature, very stable. That's when we ship them as part of the hosted platform because we don't want you to have problems in production. So if you are curious about what features are supported currently in the hosted version, we have the docs.microsoft.com page. You can head over there. This is just a little snap out of the giant matrix of features that we support. But yeah, look for the keywords FHIR features supported. All right, let's hack that data layer. All right, so this slide I added in here just to say, all right, hold up. Might give you a little bit of a overview of the lay of the landscape for the architectural components before we would jump straight into all of the code. So to give you a little bit of an idea of that, so the architectural components. So like I said, we have two data layers, and I've got two axes. I wasn't exactly sure of the best way to represent this. But on one hand, we have things that are like version agnostic and version adaptable. And this is definitely where our data layers sort of fit in. So a data layer will work with both our Stu3 package and R4 package. So our server will only run in one context. It will be either one or the other. But via the interfaces and the abstractions that we provide, your data layer will basically be able to adapt to whatever FHIR version it is that you're working with. So the one that we write here today will be able to scan files off disk. But depending on if the server is running in either of those contexts, you kind of need the same representing files on the disk as well. So we have a bunch of like core libraries as well. So core is where all of our business logic lives. The API layer kind of like includes all like the MVC controllers and filters and things like that. The web layer is a very thin veneer. So it kind of like pulls all the configuration together, has all the right includes, and basically allows us to package it up as a website. But we try to keep that one basically as empty and as thin as possible. So then we have the version-specific layers. So we're still like in process of moving as much code down as we possibly can. So we want, kind of these R4.core layers to be eventually as thin as they possibly can, basically by continuing to implement abstractions and things like that. So most code will be then agnostic and adaptable to the version of FHIR that you're working with. And then specifically for implementing the data layer, so I just wanted to drill into this as well. So there's 3 main interfaces that you would need to implement if you want to create your own data layer. So one of them is the FHIR data storage layer. So that's the one that sort of provides interfaces for like basic CRUD operations, so fetch and upsert, delete, things like that. There's an iProvide capability, so that's your data layer's opportunity to tell our FHIR server basically what it does. So it reads patient, or it has, what search parameters it's capable of supporting. So if you don't provide those capabilities, the capability statement will come out basically empty. So you can now, with fairly granular, kind of fidelity, tell the FHIR server exactly what you do, and we'll definitely look at that today. And then the last one is the search service. So the search service is, when you type in a search query, we'll parse it, we'll give you basically like an abstract syntax tree. That will come into the search service, and it's kind of like up to you to translate that into whatever syntax it is. So I also have an example of that here today as well. So what I've done on that one is simply translate it into basically like a bunch of like in-memory delegates that I can just filter over in memory. But again, it's supposed to be the simplest example possible. If you want to have a look at like production-grade data layers, again, we've got the SQL one, the CosmosDB one, and I've also got a strange branch out there which is doing it with table storage as well, just for a comparison. All right, so let's have a look at some code. That actually says it across. All right. Hang on, all I can see is the presenter view here. All right. I'm going to stop that one just for a second. All right, so this is the first example that I wanted to bring up. So here, I am working on a Mac. I am in Visual Studio for Mac for the first example. This code does look very tiny. I'll sort of zoom into the relevant parts. So if I scroll right up to the top. So here we have, file storage data provider. So I've already created some of these files just so you don't have to watch me type a lot. So these are the 2 interfaces that I was talking about, so the FHIR data storage and the iProvide capability. And then if we look across here, so you can sort of see, upsert, get, delete. If your storage layer supports transactions, you have the ability to sort of implement that interface as well. And then we have the builder method. So how we build a capability statement is we give you a capability statement builder, and that's your opportunity to kind of like do all the configuration that you need to. So if we just run this up out of the box, just going to go start without too much debugging. Hopefully I'm at the point now where this code is running reasonably well. All right, so if that is indeed running, and I do a refresh, all right, so the whole capability statement is now fitting on the screen, and the reason is it's blank. So you can see the REST node, there's nothing in there. So it's given you, because nothing's configured, there's only basic formatters that have been added, and you can even configure those yourself if you really want. So it says, we don't do anything, and if we go across here and try to, say fetch a patient, it's saying, well, that request is not allowed because you haven't said that even a GET request is available yet. So quickly going into here to add in that code in. So there's a few helper methods that we have on the capability statement builder, so just wanted to point this out, but I won't be using this one today. So if you basically supported everything, so high fidelity data store, I can do all interactions and all search parameters. You can use these extensions up here, so like add default resource interactions and then add default search parameters, and you'll just get everything that our server will possibly support. And all of those like interfaces down in the data layer, they will also, provide all that information so that you can use it. And up here, if we comment out this, so this is saying add a REST interaction for read. And I just want to do this one by itself first. So again, we'll just start without debugging. If I have to start with debugging, something may have gone wrong, but we'll see. All right, so now if I refresh getting a patient, yep, a little bit too early. So here it is. So it's basically fetching the patient, displaying it on the screen, and where does that come from? So like I said, while I was on the plane, I was looking around on my laptop, found this folder full of some Cynthia R4 patients, or bundles. So these are the actual bundles, so they've got more than patient in them. They've got, all the conditions and observations and things like that. So I have a data layer that basically parses those bundles, and now we can use the bundles as a REST API. Not totally sure that makes sense, but I wanted to prove that you can sort of adapt things a little bit to make it work with the REST endpoint. So if we zoom in up the top, we got the patient, the ID. We're saying the format is JSON, and we've also implemented the new R4 pretty parameter at the top. What that means is if I flicked over to the raw view, and you didn't have a JSON formatting plugin in your browser, we can format that output in pretty as well. Cool. So now that that's there, I also wanted to show that not only can we output the original JSON file in JSON, because we have our formatters there, we can also just output them as XML. Because it's going through the rest of the stack, and it can make that transformation. So I'm going to bring the rest of these functions in here as well. Restart. So now what I'm doing is I'm adding in the rest of the capabilities. So now we can fully utilize all the functions of this data layer. So I'll just open up get, because that's what we've just seen. So the code inside get, really, what you get passed in is a resource key, so it contains things like the version, the type, what you basically need to look up. You do that in whatever way you want. In this case, I'm reading it off file. And this is the important part that you need to return. So this resource wrapper. The resource wrapper kind of tells our system a little bit more metadata about the resource, so whether it's a history item, things like how the request was processed in this case, I don't have that because it was on disk. The last modified time. So it gives it a little bit more metadata so that we can apply like a little bit more business logic. All right, so now that's spun back up. Yep, so we can go across here. So if I have a quick look at the capability statement one more time, so now it's really filled out. But it's filled out, with only the things that we've specified. So observation has now, read, create, update, search type. So now we've also enabled conditional create and conditional update. So those have been enabled because they detected that, you have search, create, and update enabled. So this is kind of like an additional provider and capability that's provided a little bit higher up the stack. And then you can also see the search parameters. And because we know about the documentation, we've copied that through as well. So the search parameters that are here are only the ones that we've encountered in the resources inside the bundles. So we, because that's all that's there, that's all that we've, I've chosen to reflect in the capability statement, but you do have that kind of granularity. Yep, so there it all is. So if I go across here, so in this screen, I'm requesting a resource of type basic. So basic was not in the bundle, so therefore I have not added it, and therefore we still get the error message of like this action is not allowed. So we are respecting, exactly what you sort of add in there. All right, so finally, I want to do a search. So I want to also jump over to the code for search. So this is I think the minimum that you would need for search. So this is the search service. Right now you have to implement a function called search internal. Probably not the greatest name to be an override, but like I said, we're always making improvements, but what you would receive in this function would probably not change much. So in this case, it's called search options. So that's going to contain everything that we know about the search from the URL. And in this case, we've also parsed it into an expression. So this is what I was saying before. And we utilize the visitor pattern to sort of like break out the expression and know what the user has typed in the URL. And I said I have like another slide which sort of breaks that out in what you can expect from that. You do the search in whatever way you need to, and then you return an object called search results, which sort of contains everything. And you can also look at the unsupported search parameters and the unsupported sort parameters, because that for a FHIR server it is important sometimes for the FHIR server to know what you're not supporting. As I was discussing with somebody yesterday, it's important if you're doing things like conditional like creates and updates. What if they type in all unsupported search parameters, and then all of a sudden the search doesn't work, so you sort of create the record when you didn't need to. So the complex bit is where you implement the visitor. So the visitor is pretty good because you can define that your own type that you kind of get to pass through as context. So in this case, I've called mine search predicate. So it's basically just like a delegate or a function that I keep building and filtering the list of results out. So I'm just turning them into like an executable function. And you can sort of go through here, like it's only, so it's under 200 lines of code, and this will do basic like filtering and sorting. If we jump over back to the browser, and I refresh this page. Yep, so I just want to zoom in and try to show the search parameters at the top. So I'm saying, give me the results where the value quantity is less than 150 and the code is 8302-2. So if I look for those, yep, I can certainly see that I've got one of the right codes there, and I'm getting values that are less than 150. So I've got like 144. 128. So they're definitely all less than. So just to prove that it's not, like a pre-canned result. So if I go greater than, it's going to execute my delegate again. So now I'm getting, 172. So definitely my visitor and interpretation of that expression is definitely working well. All right. So I also wanted to show one more part to the search provider, not the search provider, so the data layer. So I'll jump over here into Postman. So I also decided to implement the put operation. So because we've enabled that already, and I can send that through. So I'm just doing a put against the service that I have. And if we go and have a look on disk, so I now have the example observation 001 on there, and it's written today at 9:22. That's a good reminder of the timing. And if we go back to this tab and refresh here, I can also do it didn't change because I already had it loaded, but it's done the get request on literally the resource that I put. So yeah, like this is a very simple implementation of a file storage provider. So yeah, if you have another Azure service or service somewhere else that you were wanting to store FHIR data in, this is kind of a good entry point for that. All right, let's go back to the slides here. Uh-oh, that's fine. All right. Luckily, I don't have that many slides. All right. Still with me? Yes. Like everyone's like, man, more coffee, please. It's all right. We're halfway through, so it's fine. Okay, so I just wanted to pull up this. So this is like a debug view of the search provider. At the top there, it's giving you an example of like a patient search where the name is Smith and the address is Seattle. and below that, it's giving you an example of how we've like parsed and tokenized that search. So it's broken it down into like a nice AST. It's telling you what the parameters are, telling you what that it's a token code and what the string is. So that's what that very simple search provider that I provided is basically turning into like an executable delegate. All right, so the last part, let's have a look at implementing the validate operation. So this is higher up the stack, so this is maybe using the existing data store. So this is the question that I asked earlier of like, you want an existing code base, an existing FHIR server, but you want to experiment with one of the new, operations that are coming out in FHIR, because these are new things in the spec and they can be added onto like literally any URL that already exists. So this is how you would sort of approach doing that. For this example, I'm going to go over here to Visual Studio Code, which should already be set up for me. So yes, I've hopped between environments. So Visual Studio Code, great lightweight IDE. I like doing small changes in this. You can compile and debug .NET Core in it. Before I do anything here, I just want to make sure I've stopped debugging in this window. All right. Okay, so just to have a look here, if you're familiar with ASP.NET MVC, that is exactly what this is. So everything you know about MVC is applicable here. So at the top, I've got my new validate controller. I've got this mediation component. So what this is like a little pipeline that we put all of our requests through. So in that pipeline, we also have the ability to kind of like hook into those requests and perform things like validation. So that's what I'm going to hook into in this demo. So for validate, I'm going to hook into our existing validation engine to provide the validation results like on the resource that you've posted up. We also have a lot of like helpers and collections. So this one here is a list of known routes. So this here is like the known routes.resource type, and all I want to do is append like my validate operation onto the end of that. So here is the actual POCO. So we've parsed it into a resource. It doesn't matter what the input format was. This is the POCO object, so very easy to work with there. And this one I am going to do a little bit of typing, but I have a code snippet already set up. So a few things I need to do. Turn this into an async function. So if I was compiled, so I did want to let you know about the open source project. If I was to compile this right now, it should fail, and I'll show you why. So compiling, I guess, just probably takes a few seconds. So there should be, I think, 2 or 3 build errors here. Yep, so there's 3 build errors. So you'll sort of see down here, it's coming from like code analyzers. So we have a lot of these activated in our code base to basically make sure that all of our code looks the same, even across the team. And if you're contributing to the project, you may find them annoying at first, but like I literally code this way now. It's trained me into, I guess, some kind of like optimized C# form. So what it's complaining about is like, hey, I've got like, extra spaces here. You can't commit those in. It's like wasting bytes. Get rid of them. All right. So if I remove those and do build again, this time it should go through. Yep, so that's worked. And all this is doing here, so like I said, for validate, the resources come in. I'm going to use the mediator and send a new validation request. So this is like a simple POCO message that I've set up. I'm transforming the resource into a resource element. So that's our abstraction over the resource model. So I believe the underlying types in the FHIR.NET library is like structured element. So a resource element to us kind of has a few more extensions on it that provides things like ID, last modified. So very commonly used parameters. We kind of like expose those and we grab those out with FHIRPath. So when it's done, this particular result, so we have a FHIR result, which is also an extension that we've written for MVC. So the FHIR result will, make sure that it formats the output correct for the FHIR API, and in this case, we just want an operation outcome. And we're going to select any issues that have happened, during the validation request. All right, so there's 2 more layers to go. The middle layer is setting up the validator to act on this request. So we're going to go to set up the validator. So here I'm setting up a rule to run on the resource property of the request that we've sent in. And then, I'm basically going to use our built-in resource validator. So I've not written this as part of this code example. It's already part of the code base. But I want the resource validator to validate and run on that resource. And lastly, in the operation. So this is the thing that actually handles that request from the mediator. And basically, if it gets this far, it's okay. So we've not rejected the request from the pipeline. So if it gets this far, your resource is essentially valid. All right, so let's start that without debugging. All right, looks good. And if we jump up into Postman again, so I have a patient already set up here. And if I post that there, so I've got a few mistakes in here. I've got an invalid ID, can't use that. And I've also got 2 root elements in the div, like in the generated text. If we scroll down here, it's given us multiple issues back, and it's also given us the location that's invalid. So therefore, we've implemented today, I guess, part of the validate operation. So I haven't supported like the parameter version of it, but you can sort of see the idea. Now it's just a matter of time and code, I guess. So there it is, and if I go up here and edit this to be valid. Yep, so now we're getting that OK result. So that means that the validation operation succeeded. It made it all the way to the handler. The handler said, yes, your request is good. And then it went back, and everything is OK. Cool, so that's the end of the second demo that I have. Let's just jump back into the slides for a second. Cool, so once you've been playing around with it and you want to go and host it, so in the open source project as well, we have these handy little blue deploy to Azure buttons, or the buttons in the middle of the page there. So if you click those, we've built like a template that will allow you to easily deploy all the required resources into your own Azure subscription. So it can even pull directly from a GitHub repository, compile it, and publish it also into the website. So yeah, you don't even need a like Visual Studio installed to actually deploy an instance of this thing. And if you want to think you're up to grabbing an issue and trying out some C#, we have the issues and up for grabs. So these have been vetted by the engineering team, and we think they're kind of like small enough chunks that if you wanted to get involved and try to fix part of the code base, you could kind of go in there and try to tackle these. And we have had a few contributors do that. I'm very excited when I see a PR that's not from our engineering team. It kind of gives me a lot of energy to go and review it. Yep, so yeah, have a try at those. If you see a spelling mistake, a missing link, a lot of people have also fixed those. So if that was you, thank you. Contributing, so I'm assuming if you've used GitHub, you might know this process. But yeah, our process is the same as that. Go up there, fork the code base, which is what I wanted you to do after this presentation also. It's kind of like your own personal copy of the open source project. So that'll make your own fork of the code. You can that's your playground, do whatever you want in there. And when you've made a request that you want us to incorporate, just submit a PR, and that'll come back to us. And I have an example of what those PRs look like. So the text is a little bit small here, but that'll basically kick off like our build pipeline. And don't worry, we do accept pull requests from literally anyone. This one here, you can sort of see is by my colleague Michael. He's our program manager on the team, and he's been adding some null checks in there, which is sounds like a good thing to me. So that's going to kick off the build pipeline. We do try to do very extensive validation. So again, it's pretty small, but down the bottom you can see we've run over 4,500 tests. We run multiple builds, so we build it on Linux, we build it on Windows to make sure that it's cross-platform. That's the reason why I can do all my demos on a Mac here today. We really want platform and things like that to not be an issue. We want our product to run basically anywhere that .NET Core can run. And we'll even spin up an instance of Crucible and run all of the expected Crucible tests against your PR as well. And you can sort of see this is the little pie chart that I've grabbed off there. Then we'll review your pull request. Once we're happy with it, we'll merge it in. So it looks like we were happy with Michael's pull request, and that one got merged. And that's basically it. So then you can have that really happy feeling of being part of the Git history and the little contribution menu. So going forward, we will definitely continue to add features. There's no question. We're very busy. We prioritize these features based on the things that come out in the spec, on the community, on partners, things that people add into our open source repository. So we do consider all of those things. We invite you to come and collaborate on features as well. If there's things that you want us to support before others, like let us know. That's the only way that we can do it. But if you want to collaborate on those and you want to try to implement it yourself, also that would be awesome. Some examples that I can think of is things like GraphQL. There's more advanced search operators, and there's also the new operators and things that are being defined in the spec all the time that you could also have a go at implementing it on our server. So I wasn't sure if this was the correct image for smashing out features. He definitely is smashing. So I kind of relented a little and kind of just went with, I think the good things we do will speak for themselves. So just to recap, given you an overview of the FHIR Server for Azure, kind of like a few of the architectural components, when it's good to use the open source version versus the hosted version, some of the code for hacking and extending a data layer, so you can sort of see like the minimum implementation is not a lot of code. So definitely I feel like there's a lot of opportunity to play around with it and have a go. How to add a feature, so again, most of it is just MVC, so it should be very familiar if you're familiar with C# and MVC, and then contributing and what to expect. So yeah, there's a lot of talented folks in Redmond who are working on the FHIR Server and willing to review that code. And like I said, we definitely get excited every time we see contributions from the community. So with that, we have a few minutes for questions. If you think of one later, you can tweet it, you can use the hashtag, that'll get more of the team involved. I have a link here for the code that I've presented to you, so if you want that base implementation to have a look at. And of course, like I said, if you want the high fidelity implementations, they also exist in the code. There's the URL for the FHIR server, so Microsoft/FHIR server. If you want to ask a more general question, you can do it with the tag on Stack Overflow, and the link down the bottom just goes to our API for Azure API for FHIR, like the hosted version. So if you want to take a question offline, you can come and see me at the Microsoft table at the back. I'll hang out there after this session. But yeah, apart from that, thank you all, and questions? I answered every question. Or you're all so intimidated, or like, oh my goodness. No, it's fine. Yeah, or everyone's in a morning nap. That's good. Yeah, like I said, yeah, if you think of a question later, come and see me at the table, tweet it, put it on there. If you really get stuck, you can make an issue on the open source project. But if there's nothing else, then you'll get 2 minutes back to get a head start on the coffee. Thank you all.